Hey guys, how are you doing? Hope you are doing fine. So today we are going to start another chapter of class 10 that is coming in the exams. The name of the chapter is Surface Area and Volume. That is chapter 13 of your book. And today what we are going to do, we are going to start the chapter and we will start the exercise, and the exercise will be the first one, and we will continue with the series and we will finish up the chapter as well before your exams. So let's get started. For the newcomers who are here for the first time, my name is Kong and this is Posh Coaching Classes. So let's go ahead and start the exercise. Right guys, so if we get into the chapter, it says surface area and volume. So first of all, we should understand what is the meaning of surface area and what do we mean by volume. So if we are talking about surface area, for example, if I have this thing, let it be a cube or a cuboid or any other thing, if we are taking a cylinder as well, what we are supposed to do in the surface area, we are actually supposed to check the material, the outer surface we are talking about, or even the inner surface, but not what exactly can hold up to. But when we talk about volume, then whatever thing do we have, we will talk about what is the capacity. So in volume, we talk about the capacity of the object, and in surface area we talk about the outer surface and at times the inner surface as well. But what is the capacity? We don't talk about capacity in surface area, we talk about capacity in volume, right? So now moving forward, let's get into the questions and let's see what the questions are all about. So let's see what is the first question. It says two cubes, each of volume 64 centimeter cube, are joined end to end. So we have two cubes and they have the volume, it is the same volume, and that is 64 centimeter cube. Mind you, you have to keep one more thing in mind. When we are talking about volume, it will be in cube. It can be centimeter cube, it can be meter cube as well. And find the surface area of the resulting cuboid. So we have two cubes. First of all, this is question number one. Now, what are we talking about? We have two cubes. So let's make the cubes. So if this is one cube, we have another cube just like the same, and they are joined end to end. And now both the cubes, this is cube 1 and this is cube 2. Okay, so now what does it say? It says that volume of cubes, we have volume of cubes is equal to 64 centimeter cube. Okay, now this chapter is all about formulas. You need to remember and memorize all the formulas, because without formulas I don't think you will be able to do even one question. So we need to know what is the volume of cube. So we'll write, we know that volume of cube is equal to edge cube. Okay guys, so that's the volume of cube. So now we'll just write this thing, we'll take this, volume of cube is edge cube, and this is 64 centimeter cube. Okay, so now I need to take this cube out of the picture. So now what are we going to do? We are going to take the factors of 64, 232, 216, 28, 24, 22 and 21. So we are talking about triplets. So this is one triplet and this is one, which means 2 multiplied by 2, that is 4. So that means edge square is equal to 4 centimeter cube, cube here as well. So we can take this cube and this two cube out of picture. So edge is equal to 4 centimeter. So what are we saying? We are saying that the side of a cube is 4 centimeter. Obviously all the sides will be 4 centimeter. So if we look at the actual picture, this complete thing becomes 8 centimeter. So when we were talking about cube, individually the edge of the cube was 4 centimeter. But now this is a resulting cuboid, because individually they were cubes, but then when they are taken together we get a cuboid because the sides are different. So this side and this side is different. This is 4 centimeter, this is 4 centimeter, but this becomes 8. Similarly this becomes 8 and this becomes 8 as well. So now the question is that itself, it says find the surface area of the cuboid. Now, so let's talk about this cuboid now. What do we have? We have length, breadth and height in the cuboid. So let's see, what do we have? Length 4 centimeter, breadth 4 centimeter and height is equal to 8 centimeter. Length, breadth and height. Right guys? So now what we are going to do, we need to find surface area of the resulting cuboid. Surface area of the cuboid, which is equal to twice LP plus BH plus LH. Remember guys, this is the formula, so you need to memorize this. Twice length into breadth plus breadth into height plus length into height. So what do we have? We have 2, then length 4 into breadth 4 plus breadth 4 into height 8 plus length 4 and height 8. What do we get? 16, 32 and again 32. Let's add all these. It is 16, 32, 32. 2 to 4, 6, 10. 3, 3, 6, 7, 8. So we have twice 80 centimeter square. It becomes 160 centimeter square. So surface area of the resulting cuboid is equal to 160 centimeter square. Right guys? So in one question we used two formulas. First we took the cube, individual cube, and we got the edge of the cube, this thing, and then the question itself said that both the cubes are identical. So we took these together, it became a cuboid, and then the height of the cuboid became 8 centimeter. And then we had the length, breadth and height. We used the formula, that is surface area of cuboid, that was asked by the question, and we put all the values there and we got the answer 160 centimeter square. I hope this is clear guys. So please make a note of this. In the meantime, I'll just rub this off and go to another question, right? Okay guys, so let's move to question number 2. It says a vessel is in the form of a hollow hemisphere. So let's go to question number 2. And now we have a vessel, and the vessel is in the form of a hemisphere. Let's see, you know, hemisphere is somewhat like this. Okay, now mounted by a hollow cylinder. So we have a cylinder on top of this. So let the cylinder be here. Now this is the actual shape of the vessel. Now what further it says the diameter of the hemisphere. So the diameter of hemisphere is 14 centimeter. What else? The total height of the vessel. The total height of the vessel is 13 centimeter. And that's about it. Find the inner surface area of the vessel. So what we are going to find? We are going to find the surface area of the vessel. So let's do a few things first. First of all, it is given the diameter of west hemisphere is equal to 14 centimeter. So obviously radius of hemisphere will be 14 upon 2 centimeter, that is 7 centimeter. So let's do a small thing here. Obviously I'll put a dotted line here, and from the center, if I take a line down, it will be the radius because it's a part of a circle or a sphere. So this will also be 7 centimeter, right? Now If this is 7, this is 7, and this also will be 7. Now, one more thing was given, that is total height of the vessel. It was 13 centimeter. Now, if we talk about just the height of the cylinder, obviously that will be till here. So what are we looking at? We are looking at the actual height, that is 13 centimeter, and this height is 7. So I'll just deduct 7 from 13 centimeter, that becomes 6 centimeter. So this is the height of the cylinder. Now, what does it say? It says find the inner surface area of the cylinder. Now we'll say we know that inner surface area of, not the cylinder, the complete vessel, inner surface area of the vessel, it will be surface area of cylinder plus surface area of hemisphere, because we have both things here. One is cylinder and then we have hemisphere. So what do? Surface area of cylinder is 2 pi r h, and then we have surface area of hemisphere, that is 2 pi r square. Okay guys, again as I said, remember the formulas. You need to memorize all the formulas for these questions. Surface area of cylinder 2 pi r h, surface area of hemisphere 2 pi r square. One thing we need to check, if the value of pi is given. Yes, in the question you have the value of pi, and the pi is given 22/7. If it is given, use that. Now what are we going to do? I can see here, I can take 2 pi and r common, and then I have h plus 2 is out, pi is out, we have square here, 1 r is out, then put 1 r here, 2, then 22/7. Then what is the value of r? Radius is 7 centimeter. Then what is the value of h? Then this h is the height of the cylinder, that is 6, plus r is 7. Now this 7 and 7 goes, 2 multiplied by 2 is 44, into 6 plus 7 is 13. Let us multiply. 3 for 12, 2 for 12, 13, 4, 4, 2, that is 7, that is 5, and the question was in centimeter. So surface area, as I said, will be in centimeter square. So what do we have? We have 572 centimeters square. That is the answer of your second question, and I hope this is clear. This is an important question, guys. What was there? There was a cylinder and a hemisphere. The hemisphere was at the bottom and cylinder on the top of it, and then we got all the things what was given in the question. The total height was given, and then we did the calculation, used two formulas again in this question. One was surface area of cylinder, and then we used the surface area of hemisphere, and then rest is the calculation, and that is pretty simple one. So I think this is much clearer to you. So now let's move to question number 3. In the meantime, you can make a note of this. You can pause the video and make a note of this, and I will just rub this off now. So let me go ahead. Okay guys, so let's move on to question number 3 of this particular exercise. Again, we have another thing, and it is a toy. What does it say? It says a toy is in the form of a cone of radius 3.5 centimeter. So we have a toy, and the toy is in the form of a cone of radius, we will check that later, mounted on a hemisphere of same radius. We have another hemisphere here, as we had in our previous question. So this is the shape of the toy. Now the radius of the toy, let me write it here. It says radius of the cone is equal to 3.5 centimeter. Okay, now even the radius of hemisphere is exactly the same, that is 3.5 centimeter. Now it says the total height of the toy is 15.5 centimeter. So if we talk about the total height, that is 15.5 centimeter. Okay. Now the radius is 3.5, as we did in our previous question itself. This is 3.5. So what will be the height of just the cone? We will just see it here. Now we'll say height of the cone. The total height is 15.5 centimeter. We will deduct the height of the cylinder. What it is the radius. So we can take it the height, and it will be 3.5 centimeter, which becomes 12 centimeters. So the height of the cone is 12 centimeter. Now we are done with all the things what we can do there. Now let's see what it says. It says find the total surface area of the toy. So we need to find the total surface area of the toy. Let us write it here. Total surface area of toy. What are the two things that we have here? We have to find surface area of cone, and then we have to add surface area of hemisphere. Okay. Now if we see total surface area of toy, I'll put the formula. Surface area of cone is pi r L, and surface area of hemisphere we just used it, that is 2 pi r square. Now this thing is clear to us. 2 is okay, pi is okay. If the value is given, we'll use that. R is also there. But what about this L? We have an L here, and the L means, if I write it here, L is slant height. What is L? L is known as slant height. And what is slant height? This thing. This is the perpendicular. This is not the perpendicular. If I take this triangle, this is the hypotenuse. So this is known as slant height. Now, to get the answer, we need to find the slant height. So that's what I was just talking about. Let me take this triangle. Let me put a name here, AOB. I'll say, taking triangle AOB, right angled at O, using Pythagoras theorem. Very important theorem, guys. Hypotenuse square is equal to base square plus perpendicular square. Hypotenuse, that's what we are looking for, so let it be L square. Base, you remove it, this is 3.5, again this is 3.5, so this is 3.5 square. And perpendicular is 12 centimeter square. So L square, if we multiply 3.5 with 3.5, what do we get? 25, 5 is 17, 15, 10. So that is 5, 2, 2, 1. So 1 to 12.25 centimeter square. Plus, if we multiply 12 with 12, it becomes 144 centimeter square. So we have to add 144 to 12.25, that is 156.25. L square is equal to 156.25 centimeter square. I hope this is clear till now. Now, what are we going to do? We are going to take this L square, I'll write it here itself. It's L square is equal to 15625 upon 100. I'm just taking the decimal out of picture, so I have put in 100 here. Okay guys, so we have L square is equal to 15625 upon 100. So let me take the value of, let me get the value of 15625. Let me get the root of this particular thing. It will be 125. Let me check it one more time. So it is 15625. It is absolutely 125 upon, and then 100. You know it is 10. If we multiply 10 twice, 10 multiplied by 10, obviously it will be 100. And 125 multiplied by 125 is 15625. So this square and this square, I'll leave it, and then we have 12.5. using the denominator, I got the value of L. Now, we are not finished yet. Why? Because we have to get this thing. Now, if we talk about surface area, total surface area, that is pi RL. That is pi RL plus 2 pi R squared. Let me take pi and R common. What do I have? I have L plus 2R. Anything given here? Let me see. The pi, the value of pi is 22.7. Then R is 3.5. L, we just got 12.5 plus 2 into R, that is 3.5. Okay, so 22 upon 7 into 35 upon 10, and then it is 12.5 plus 2 multiplied by 3 is 3.5 is 7.0, that is 7,552 to 11. Now what do we have? 11. 12.5 plus 7 is 19.5. Now if we multiply 19.5 with 11, what do we get? 19.5 multiplied by 11 is 214.5, and the question was in centimeters, so that is centimeters squared. Hope guys, is this clear? So that's our question number 3. So this is the value of this whole thing, the surface area of the entire toy, what was given there. So that's about it. Now let's move on to question number 4, and please make a note of this question as well. Very important question, and I hope you got the this L. You got this L, what this L means, and how do we find the value of L. And after using the Pythagoras theorem, we can easily get the value of L. Right guys, so let's move on to question number 4. Make a note of this. I'll just log this off. Hey guys, so question number 4, what does it say? It says cubical box or a cubical block of size 7 centimeters is surmounted by a hemisphere. So we have a cubical box. I'm just trying to make it. Let this be the cubical box. Now it says it is surmounted by a hemisphere. So we have a hemisphere on top of this thing. Now, a cubical block of size 7 centimeters. So we have the cubical block, that is cube is there. So edge of the cube is equal to 7 centimeter. Is surmounted by a hemisphere. What is the greatest diameter of the hemisphere can have? So what does it say? It says what is the greatest diameter of the hemisphere that we can surmount on it. So obviously it will be 7 centimeter. Greatest diameter for the hemisphere, because that's the maximum it can take. So that is 7 centimeter. Now what it says, find the surface area of the solid. So now we have to find the surface area of this entire solid. So this is the diameter as well, 7 centimeter. So what are we talking about? We are talking about two things here. One is cube, then we have the hemisphere as well. So now it says find the surface area. Surface area of the solid. So what do we have? We have two things first of all. So first we will say surface area of cube. Then we will find surface area of hemisphere. Now, mind you guys, there's one thing that you need to take into consideration. So see this part, the part of the hemisphere which is on top of the cube, obviously we have a part already there, that is the side of the cube. So if we put the hemisphere on that, it will be twice. So what we will do, we will just take this out of the actual solid. So we will take area of circle, we'll deduct area of circle from it. I hope this is clear guys. We have a side for example, this is the topmost side of the cube, and then I'm putting a hemisphere on it. So the hemisphere will be on top of the cube. So there will be two things. One is the side of the cube, and then one is the upper side of the hemisphere. So those two things will be on top of each other. So we will deduct one thing so that we will get the actual thing. Now, side of cube, we know surface area of solid. Side of cube is 6 into edge. This is the formula. Square plus surface area of hemisphere 2 pi r square minus area of circle pi r square. Okay. So do we have all these things? We have the edge. Yes, we do have. We have the radius. We can get it here. We can write radius of hemisphere. If the diameter is 7, radius will be 7/2 centimeter. Now we have all the things. So okay guys, so let us put all the values, and before that I can see one thing. We'll write 6 into edge square. This is 2 pi r square, then we have to deduct pi r square. So I will have only pi r square left here. Right guys, 2 pi r square minus pi r square. So now this 6 edge is 7 square, then pi, do we have pi there? Yes, it's 22/7. R is 7/2. We have to write it twice because this is square. So now this 7 and 7 goes, this 2, 11. Now we have 6, 7 into 7, 49. Then what do we have? Plus 11 into 7 is 77/2. So if we multiply 6 multiplied by 49, 6 multiplied by 49 is 294 plus 77 divided by 2 is 38.5. Obviously this is centimeter square. And now if we add both of these, 38.5 plus 294, it gives us the value 332.5 centimeter square. 332.5 centimeter square. That is the answer for this particular question. I hope this is clear guys. I hope this part is clear, because this is the only tricky part. Apart from that, everything else is very simple. You need to just try and understand what I'm trying to make you understand is that we have two things. One is surmounted over the other. We have the surfaces, coinciding. We have two surfaces, one surface on top of another. So we have to deduct one, otherwise we will get the surface area of this, we'll get the surface area of this if we talk about separately. But when we combine them together, this surface area will not be the actual surface area if we see just combining by these two things. We need to deduct this area of the circle because it is twice there. It is there 2 times. One for hemisphere and other for the cube. So one has to go. So that's what we did. And then rest is just the calculation, very simple calculation. Surface area of cube, another formula, that is 6 into edge square. Then surface area of hemisphere, we used it in previous questions as well. Area of circle, you have used it in 7th and 8th standard as well. Then just the calculation. I hope this is clear guys. So we are done with question number 5 as well. The exercise is not finished yet. We will not make this video long. So let us finish it here itself. And for the rest of the questions, I will be coming back to you again in a couple of days. So please do watch this entire video, and please do subscribe to our channel if you like the video. Please do subscribe and share the video as well, whoever is in need of this particular chapter. So that's me signing off for today. You have a wonderful time. You take care. Enjoy. Take care.